Hello, my dear student. I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of rotation of a rigid body for our subtopic of the moment of inertia. So before we proceed with our discussion here, we were supposed to remember where we ended on the last session. But on the last session, my dear student, we tried to see some examples related with the ring. We tried to demonstrate and solve that questions, and after there we tried to look for the moment of inertia of a sphere, and we started how can we demonstrate the moment of inertia for a solid sphere. That is where we ended on the last session, and we said that the sphere is categorized into two parts. It means we are going to look for that solid sphere and also for that of the hollow sphere. So after looking for that, my dear student, we ended on how we can demonstrate the moment of inertia for the moment of inertia for a solid sphere. And we say that moment of inertia of the sphere is obtained by imagining that we have the sphere, and that sphere containing the elemental disk inside. And we ended on how we can demonstrate the mass, the mass of we ended on how we can demonstrate the mass of the elemental sphere. That is what we tried to look. So today we are going to look how can we consider the question number 8 that I imagine for our figure number 4.8. Now let us work together with our figure number 4.8. As I told you that this was the 8th figure on our fourth topic. So we say that from our figure there, we tried to see that if we contain the triangle that are found inside the solid sphere, we should obtain that. I know that if we take that triangle and recall the Pythagoras theory that a square plus b square must be equal to c square, that the hypotenuse square must be equal to adjacent square, then we add it by the opposite square. Now, for the relationship of our value that we have on our triangle that we tried to remove into our solid sphere, now we should say that y square must be equals to, the r square must be equals to y square plus the a square. The a square represents the radius of the elemental sphere. That is what we tried to see. So after this one, now we are going to focus how can we get the distance of the elemental sphere. And we could say that we could get that by making it the subject. From r square is equals to y square plus the a square. Now we should make a square at the subject, and we obtain that a square must be equals to r square minus y square. This should be how can we obtain the distance of the elemental sphere for our figure. It means for our triangle that we try to remove into our solid sphere. So after that one, my dear student, now we are supposed to take this a square and also the mass of the elemental sphere or the elemental disk and substitute into our equation that we try to look for our equation number 30 on our first topic. Now let us take a dm and also a square and demonstrate it. And our equation on 4.30, we say that di must be equal to half dm times the a square. But dm we try to demonstrate on our past subset on our last session by saying that this should be obtained from the relationship of the elemental mass and also the volume. That is what we tried to see. So if we take the m that we tried to make to demonstrate on our past session, now if we take and substitute into our equation number 30 here, it means I have dm a square and also the value of a square, we should obtain that the I which represents the moment of inertia, the I which represents the moment of inertia of that elemental sphere must be equal of the solid sphere, must be equals to 3m, then we multiply bracket times r square minus y square. This come up after pressing the a square here. If we remove the a square, we should obtain r square minus y square, then bracket the square. Now, after this one times the dy, then we divide by 8r cube. This implies the volume. After this, my dear student, now this should be the equation number 4.33. Our equation number 33 for our 4C topic here. We should say that di must be equals to 3m, then bracket the r square minus y square exponent 2, as we observe, divided by 8r square. Then we multiply it by dy. Now, after this one, my dear student, let us come up for our equation here. Now, what we are supposed to do here is to expand our equation. Let us expand our equation. And after expanding our equation, we are supposed to introduce the integral, or you can introduce the integral. After introducing the integral, now we are supposed to expand our equation so that it can be simple to integrate. If you should integrate by this one with respect to dy here, it is easy. Unaweza ukajaribu kwa directly au unaweza ukai-expand. I know that if you should expand here, it will be simple for you to integrate. Lakini unaweza ukaenda kwa njia moja kwa moja na penyewe japo itakupa ugumu kidogo kwa sababu uta integrate kwa kuleti. Takachokifanya, we should factor out the 3m over 8r cube. If we put it out here, the integral will be between 3m and also the 8r cube. And after there, my dear student, we should introduce the integral, then we expand this one. And after there, we take dy, we multiply inside. This should be r, it means r power 4. It should be r power 4. Then we minus it by 2r square y square. Then we add it by r power by y power 3 power 4. It means we multiply by dy for every value that are found inside. Now, after this one, my dear student, what we are supposed to do after this one? After expanding, we should introduce the integral for each value with respect to dy. If we integrate, as we know that, as I told you that this after expanding this one, it should give us r power 4. Then we minus it by 2r power 2 y power 2. Then we add it by y power 4 here. Now, after this one, my dear student, what we are supposed to do, if we apply integral for r power 4 dy, this should give us r power outside here. It should be 3m, then 8r cube, and after there, it should give us equals to r power 4 y. Then we minus it by 2r square y power 3, because here we was having y equal y involving the exponent which is equal to 3 here, as we try to observe. Kwa ilikuwa ni power 2. Ukiintegrate tuna add 1 kwenye exponent and also at the downward tunachukua ule exponent tunamweka chini. So after this one, if we integrate y power 4 after expanding, we should obtain that this y power, it means the y power 4 on integration with respect to y, it should be obtaining this y power 5 divided by 5. And after this one, now we are supposed to introduce the limit. As we know that because for di here, we was tried to integrate it from 0 up to I, but here now we are assuming that the solid sphere trying to rotate from negative r up to r. That is why we try to introduce the limit negative r up to r, my dear students. So after this one, we are supposed to, after integrating, now this should be the question number 35. And we are supposed to go and after we are supposed to go and introduce their limit. It means to substitute the limit zetu respect to y, my dear students, what we are going to obtain.